Hello guys, in this video we'll discuss how to create banking account. We will use Akka and Scala language. So Akka is a framework for creating multi-threading applications. It has this interesting approach for those who didn't use it, so-called Actror Model. And we will use it and I will explain why it's important and why it's beneficial and when we can use it. And we will go and talk about some related stuff while doing this. And it could be useful for many of you guys. So let's go and start with something. First of all, we'll create a new application and it's gonna be Scala, right? With SBT. We'll create it with the name banking account, right? SBT, I use SBT 1.8, Scala 2.13, as you can see. Okay, let's continue with that. So far we have this empty project and we can go and create, we have to add dependency to Akka. Okay, yes, to do this, let's type something. So you see we have this configuration root for the root folder. This is our project SBT. It has a name. I have to add one more field, which will be library dependencies. Library dependencies plus plus equals sequence. So it's going to be a sequence of dependencies that we will add. First package, type save, Akka, then select that, %%, then the artifact name, Akka, Akka actor typed. Then we'll create a version. We'll use the version. Akka version. So let's define it somewhere here. Wow. Akka version. So we'll use the latest for now. I think is this, and we'll type it there. So we'll see if it works. So what's going on here? This is like that. Plus plus. Yeah, plus plus equal like that. Okay, so that's everything we need, I think, for now. Type save wise. Yeah, so let's go from there. Then press on this button just to refresh to resolve the dependency, and we will know if it's okay. As you can see, I use Java 11 for now. You can use maybe 17. That's available as well. So what's going on here? Let's check. Not found repository. So most likely I did some typo. Type save. Type, yeah, exactly. Type save. Yeah, actually it provides these hints and I could have used them. Okay. Okay, now it's fine. So what we're gonna do is let's create some package. Banking, let's say. I call this project banking account, but I guess I should have called it bank account to be it more English, right? So let's go and create bank account object. Just a demo, you know. So we will extend it with up. So this will let us, this way we will simply be able to run this. You see, this triangle is here, so we can run this application. Right now, if we run it, we're gonna have nothing, which is fine. Yeah. So what about that? So what we're gonna create actually here, just to make this example more live, we'll create two objects. First, it's gonna be a person, and second will be a bank account. Okay, So this way, like person will talk to bank account, right? And it's going to be an interaction between them. And that person will be able to do what? Deposit, operations like deposit, withdraw. Second, it's going to be withdraw. And third, it's going to be, let's say, statement, get statement or something like that. So you can get statement. So that's, I think, everything we need for now. Let's go and create this. The way it works with an actor model, it's easy. So we just create a person, okay, class person, and it extends an actor. So you can guess the actor is someone that can be, like on the stage, you see. We're going to have two actors, one that will behave on the stage as a person, and another will behave as a bank account. That's it. So let's go and implement some method. This method receive is our handler basically. And if you go and check what is this receive is about, the type that it will return is going to be some interesting stuff about it. So this is like a partial function. You can read about partial function yourself, but everything that I made to let you know right now, that partial function is something that the function that is not fully implemented in a way, not fully applied in a way. So let's say if we have a function like that, right? So let's say function, I don't know, like a sinus, all right? Sinus. This is like a fully applied function. But let's say if that sinus would get some other parameter, some x parameter, oops, some x parameter, but we're dealing only with that one, not filling this x. It means that this is like a partial function, and it's okay for function to exist without being filled fully. Okay, so that's everything you need to know for now, but you can go and check more about this. Okay, let's go and implement this function. First of all, it's a person, right? Probably we don't need to implement anything yet. I'll just fill it like that. Okay, I'll keep it like that so we can go to the next step. The next step will be we'll create a class bank account. Now our another actor. Account extends actor. Yeah, it's kind of easier to deal with bank account for this stage. Okay, receive. Same thing. Also, there is nothing to implement. So the next step, what we know about our banking world is that we have this deposit, withdraw, and get statements. This is something that a person actor will send to bank account. All right, and let's take it into account into account. Let's imagine that person sent a message to us. This everything. What you need to know is that when person communicates to bank account, when two actors communicate to each other, they send in messages to each other. Okay, messages. And these messages will be basically our operations with the account, like deposit and withdraw, etc. So that's why let's go and implement this. Let's go and implement these messages. To implement this, it's going to be like a case class deposit. Money, so it's going to be money, like big decimal. Let's say we're going to use big decimal. Another case class Basically, the case class is just a class with getter and setters in short, right? And this is the constructor. So it's easy to think about this like this, if you don't know. Then withdraw, then get statement. The get statement doesn't need to have any parameter, actually. Let's go for them. Then on the bank account side, this is bank account, and let's say we receive deposit. This is how it works. It's like a pattern matching. It's called pattern matching because we are matching that whatever comes to us, right? So in case if deposit comes, we will do something about it. So let's say as soon as we receive a message, money, we will type something as yeah, I'll show you some trick here. Every actor has a context. Okay, context, and this context could be reached by like this. 1 second, yeah, like that. Context, and this context is self. So self is like a reference to this actor, right? Because I just need to, what I need to do is as soon as we receive a deposit, I will print it, like log it to the console to know which actor received it. And this context self will have some kind of name and ID in it for this specific actor whenever it is placed. Okay. Then I can say something like got deposit, and what is the deposit value will be this money basically. Let's just keep it short, maybe like V, like value of deposit. Okay. Yes, value of deposit. Okay, good. What the next one? So we're printing this, that's fine, but we have to have some kind of balance on our account. And this balance will be a big decimal, like we said before. And initially start with 0. So we don't have anything at all, right? So, and imagine as soon as we have deposits received, the value, we will increase the balance by this value. So that's what we have to do. Okay, so very easy. And the same thing we can implement withdraw right away because it's kind of logical. Withdraw right away. We got withdraw. Okay, and the balance will be minus equal this. Another thing, as we said, we're gonna have this get statement case. So whenever user asks to get the statement of the account, we will show the statement. We'll not implement it right away. I'll just put a placeholder. These 3 question marks stands for placeholder, as you guessed already. So let's test this, right? Because we just type in. It's time to test something. First thing we have to create actually actor system. Actor system. And actor system. So what is actor system? It's just this actor thing is a framework or library, and to get some actor registered, we have to create a system, actor system, and register it there. right? So there could be many systems in the application, but in our case, you can name them logically. Let's say you have banking subsystem, right? Then you have reporting subsystem. So in this case, we just name it like bank account system. Okay. Important point is that the name should go without space. Otherwise, you will get an exception. Okay. Once you get this actor system, now you can register or create or register a new actor. The way to do is like that with props. So in our case, what we have two of them, person and bank account. Let's say person, that's it, and bank account. Bank account. Let's name them person, bank account. Yeah. What is interesting piece also here that the return type that we get out of this actor registration is a reference to the actor. That is important point because this is different from classical object-oriented approach. So when you call an object-oriented approach, you have a person and then you call something on it, right? But here it's explicitly said that it's not a kind of object itself, it's a reference to the object. And it could be like even a remote reference to the object. And when you call something on the actor, you're actually not calling a method. You are sending a message to it. Okay. So, and in this case, to send a message, we'll start with the bank account probably. To send a message to it, you will use this method, explanation mark. This actually method that's same as tell. You know, it's also called like a tell method, but it looks like this, explanation mark. And we're gonna deposit something. So let's deposit $500 to it. And let's deposit it one more time. And then last we'll do withdraw. Withdraw, I don't know, let's say 500. Let's keep it like that. Okay. So, and that's the first thing. So we did this and let's test it. We just run it like that. If I miss something or if something is not clear, please let me know in the comments, by the way. Let's see what's going on. Oh, you see, we have 3 messages received. This actor bank account system, blah, blah, register this ID of this actor, which is bank account. There is, we cannot know that it's a bank account from the name, right? It's just bank account system. It's printed. But anyway. So we got deposit 50, we got deposit 500, I mean 500, and then we got withdraw. Okay, so it seems like working. So what just happened? It's pretty. It should be pretty straightforward and easy to understand. We just sent 2 messages, 3 messages actually, to this actor. So we sent a deposit, so it printed this message. Then we sent it again deposit, it printed that message, and then we withdraw. Let's say we're gonna implement something with the get statement. Now, you know what? Get statement will wait. Everything is good so far, but as we initially said, we wanted that person we're talking to banking account, right? Bank account, not just some out of space message or coming to bank account. So let's do this. But right, as you can see right now, we're just having a reference to bank account and sending it right away from nowhere. but we have to do it from the person. How to do this? Mm -hmm. So I imagine we can do something like that. You see, we have a person, we have a bank account, then I'll comment this out for now. Then the person will have to send a message to a person just to initialize something. And this message could be just some kind of init message, you know, like something like that. But I would name it something like leave the life. Leave the life. So as person is living his life or her life, he or she will be spending money. That's basically the idea. And let's create this yet another message case class leave the life. The best way to create it, by the way, it's not just on top of banking account, but in some namespace. Yeah. For that, let's create something that we haven't had yet. We'll create a companion object. So it's like object person. Companion object is object with the same name as a class, so they kind of like connected, like a companion, right? And then here we can create this live their life, meaning that we kind of saying that this live their life message correspond to the person namespace. Okay, same stuff. We'll do same for banking account. So right now we're doing some kind of refactoring. Right? Object, bank account, like that. And we'll just move this here. Everything's supposed to work here if we import bank account stuff. Okay, same for here. Leave the live. We're supposed to import this message from import person from the person. Okay, so this way, as soon as we import something like leave the live message, we can use it. And yes, indeed, in this case, we really sending this leave the live message out of the space from nowhere. So there's no zero component or space actors system or something that send the message to the person. It's just a first message from nowhere. Live the life. You know, the miracle of life creation. Let's call it this way. Okay. So this is how to look at this. So what did we create so far? Let's summarize. We created this object namespace. We created this object person namespace. So far, so good. So leave the life. Let's handle this. As you can see, this person, actor, in case if we receive a message leave the life, we will start spending money. Yes, and the way we will do it, we'll just move these messages here. So you see, this person goes and deposits something, so he's working hard or hardly working, and then withdrawing some money to buy something. You know, that's a scenario we have right now. Let's run it. So this still working fine. What just happened? We sent a message to the person, leave the life, and it used banking account reference to banking account and start using this banking account to leave his or her life. That's how it works. Okay. So far so good. Let's go to the next step. Let's implement the get statement. What is interesting about GetStatement? So first of all, let's define what a statement is. Statement is like a list of transactions, okay? List of operations, if you will. One operation, another operation. Like we have two operations: deposit, then withdraw. So the way it will look like, let's say deposit one. I mean, deposit, second deposit, and then withdraw, like that. This is what it is. And another thing is the statement supposed to have two fields, like what we did and how much balance still left, like a current balance, right? Yes, same here. Okay, so that's what we expect. So let's go and create. We have to create some kind of structure basically for our transactions. Yeah. So in this case, it will be val value statement, and in this case, I will use a list, but with buffer actually, because it's okay to use mutable list because we are inside of the actor. I will explain about this later. And I will use some kind of structure. Let's say I'll call it statement record. It doesn't exist yet. I will create it in this namespace. It's going to be a case class record, like we said with deposit. So it's going to be operation. So one of this operation, deposit and withdraw. Right. So it's going to be this operation here, and yeah, let's say operation. We don't have this yet, and balance. Balance gonna be big decimal. These two operations are operations, right? But I cannot just use deposit or withdraw here because I need to have a common class. In this case, it will be trade operations, and I extend from trade. Okay, it's like an interface thing in a way. Good. Okay, so what's going on here? Case class. Statement. Okay, and then we have to import this, of course. We did import it, but yeah, not here, not here. We have to import it in there. That's kind of like a best practice, I think. So we import it where we use it. Same here. Yes. So statement. Statement is just a list of statement records, right? Right now, let's go and implement the method GetStatement. It's relatively easy to do. So let's print something. Print, same thing as we did before. It's gonna be context self. Then what exactly we're doing? We like got statement message, right? And we can say exactly what it is. Statement is statement is something. And then because the statement itself is what is a list, we can go over this list. What's going on? Why we cannot go? Yeah. So there is something, a list buffer. A list buffer probably something that's not what we're expecting. List buffer. Let's figure out what it is. So this should be actually, yeah, I understand. Yeah, let's just put it list here, right? List buffer. Interesting. This list buffer is supposed to go, we have multiple implementation of it, right? We're supposed to use, not this one, it's supposed to be from mutable library. Okay, let's fix it. Why did we import it? Yeah, this is okay, it seems. Yeah, mutable, that's fine. It's exactly fine. It's like that. So list buffer, it's a build. Okay, I understand. That's what I'm missing. List buffer and a constructor, because it's a class, it's not an object. So right now we're going for each by statement, and for each record that we got from there, record, we'll print every record basically. And it's better to do this way because it's easy to think. Okay, so we'll just print every record. Print ln as record. That's what we will do. I prefer to put curly braces or braces as always. Okay, so this is the get statement. Let's see what happens. We're going back to this method of the person who is living the life. So he or she is doing all these operations, and then he wants to see. I will say he just because I'm referring to myself, right? So let's see. He wants to send a message to withdraw message. Okay, and then it's supposed to have something. Withdraw, not withdraw. Come on. We will use the message balance. Get balance. Get balance. Balance. Like that. We have to import it from. Yeah, not. Yeah. Get statement. Get statement, not balance. Exactly. So get statement. So we'll send a message get statement to see what do we have. In this case, you see the statement is, and there is nothing. Why there is nothing? Because we haven't registered anything in the statement as we do our operation, as we proceed with our operations. So let's fix it. So basically for these two operations, withdraw, etc., we have to modify the statement. So in this case, it's going to be statement We have to add the statement record plus equal, right? Statement record, and the record is, in this case, is deposit V. It's kind of duplicating ourselves, and the current balance for this moment. And same for withdraw. Minus this. Actually, not minus. It's always plus, because statement is a list of statements, and we're always adding something, not not removing anything from it. And so in this case, it's not a deposit; it's a withdrawal operation. So let's call it again. You see, statement is statement record deposit. So we deposit 500, we deposit 500, and then we did the statement withdraw with 500, and then at the moment of withdrawal we got $500. Okay, I mean after. So this seems how this is how it works. Let's summarize what we did. So we created two objects, person and bank account. Those two objects those two objects are the actors. The actors is actor system from Scala, a Scala implementation, actor system. So we use these two, and we did this. We implemented the balance. We implemented the statement. We checked. We went through three cases like withdraw, deposit, and get statement, where deposit and withdraw are the operations that we do. Yeah, don't forget about this. This is how we registered the system, actor system, and created a reference to our two objects, which could be a remote object. And then we initiated the life of this person, banking life, and everything start spinning basically, right? All these operations start popping up in the logs. What is interesting about this implementation, if you compare it to classical object-oriented one, you probably noticed that we don't have any synchronization here. We don't care much about multi-threading in a way, because imagine if you do this with a classical object-oriented approach, you would have probably two methods: withdraw and deposit and withdraw. And these two methods supposed to be synchronized like this, right? Synchronized, blah, blah, synchronized, to be able to deal with these race conditions and then possible deadlocks, life locks, and all that stuff. But in this case, when we use actors, we don't care about this, and the implementation become really easier in this case, right? Because we don't need to think about all that bad scenarios in regards to error handling, in regards to um, multi-threading and all these issues that could pop up out of this. Okay, so in this case, this is like easier to implement these scenarios like that, multi-threading scenarios like that, and that's the beauty of actor system. The way it works, again, the way it works in general, that the idea is that in every moment of time, there is only one thread that could live inside of actor. You know, so basically this receive method is thread safe because nobody else is calling it, And the way it works also inside of the actor, every time when you send a message to actor is asynchronous. Everything is done in a synchronous fashion, meaning that there is no any block in here when person leaves a live, right? We sent a message, we sent a message, we sent a message. We don't wait here until bank account, handle it. We're just sending it one after another, everything asynchronously, right? And you might think that, okay, because we send it this asynchronously, how come that, how it's possible that actor can handle it sequentially, right? How does it work? So the way it works is like um, every actor has something like an inbox inside itself, inbox, and you can think about inbox like a queue, right? So every message you send, it will go first to inbox queue, and then as soon as actor is ready, it will go to receive method and being processed. That's how it works. So theoretically, if you wanted, you could implement the actor itself somehow. You probably could use some MQ MQ dedicated MQ for each class, and do this manually. This how would it work? But the actor gives you all this infrastructure, give it for out of the box, and it's not only that. The integration between actors and the way the communications is also there, something that we haven't covered yet. So you can imagine that everything is working in integration. There are many other cases that we can tackle, especially about the state of the actor, etc. Right? Like in this case, like I said, we didn't care about the synchronizing the state. We even don't think about whether it's mutable, not mutable. So it's really mutable state, and we can deal with this state safely in safely fashion. Um, and in this case, it's easier to think about object-oriented model being on actor side of things. I would put it this way. So hope this was useful for you guys, and if you have some questions, just post this in the comments below, and bye for now.